Inverse trigonometric functions are commonly used in engineering, construction, and architecture. One common example of an inverse circular function is the angle of depression and angle of elevation. Engineers would have to calculate the angle of a bridge and supports when drawing outlines. These calculations are then applied to find the safest angle. The workers would then use these calculations to build the bridge. Definition: if sin theta equals to x, then the measure of the angle theta is sin inverse of x. We write theta equals to sin inverse x. For example, since sin pi by 6 equals to half, then pi by 6 equals to sin inverse half. Similarly, we know that tan pi by 2 equals to infinity, then tan inverse infinity equals to pi by 2. Remark: we always remember that we have never to think sin inverse x equals to sin x whole inverse, because sin x whole inverse equals to 1 by sin x. Domain of inverse: the inverse may not exist for all values. For example, sin inverse 4 has no value because for any value of theta, sin theta is not equal to 4. A table is shown here which gives the measure of the angles are defined in which range. Here sin inverse x and cos inverse x both are defined when x lies between -1 less or equals to x less or equals to +1. For cosec inverse x and sec inverse x both are defined when x greater or equals to 1 and x less or equals to -1. For tan inverse x and cot inverse x, they both defined for all values of x. Now the formulae. There are so many formulae belonging to the chapter which are very useful in solving different types of problems. These formulae here arranged in different sets regarding these types. These should be committed to memory so that at any moment when required we can recall. So set 1. Sin inverse x equals to x, cos inverse x equals to x, tan inverse x equals to x, cosec inverse x equals to x, sec inverse x equals to x, cot inverse x equals to x. Set 2. Sin inverse sin x equals to x, cos inverse cos x equals to x, tan inverse tan x equals to x, cosec inverse cosec x equals to x, sec inverse sec x equals to x, cot inverse cot x equals to x. Set 3. Sin inverse x equals to cos inverse square root of 1 minus x square. And secondly, cos inverse x equals to sin inverse square root of 1 minus x square. Set 4. Sin inverse minus x equals to minus sin inverse x. Listen here. Cos inverse minus x equals to pi minus cos inverse x. Tan inverse minus x equals to minus tan inverse x. Cosec inverse minus x equals to minus cosec inverse x. Sec inverse minus x equals to pi minus sec inverse x. And finally, cot inverse minus x equals to pi minus cot inverse x. Set 5. Sin inverse x equals to cosec inverse 1 by x, cosec inverse x equals to sin inverse 1 by x, cos inverse x equals to sec inverse 1 by x, sec inverse x equals to cos inverse 1 by x, tan inverse x equals to cot inverse 1 by x, and cot inverse x equals to tan inverse 1 by x. Set 6. Sin inverse x plus cos inverse x equals to pi by 2. Tan inverse x plus cot inverse x equals to pi by 2 when x greater than 0 and equals to minus 2 when x less than 0. And thirdly, sec inverse x plus cosec inverse x equals to pi by 2. Set 7. Sin inverse x plus sin inverse y equals to sin inverse inside second bracket x into square root of 1 minus y square plus y into square root of 1 minus x square. And secondly, sin inverse x minus sin inverse y equals to sin inverse inside second bracket x into square root of 1 minus y square minus y into square root of 1 minus x square. Set 8. Cos inverse x plus cos inverse y equals to cos inverse inside second bracket xy minus inside square root 1 minus x square into 1 minus y square. And secondly, cos inverse x minus cos inverse y equals to cos inverse inside second bracket xy plus square root of 1 minus x square into 1 minus y square. Set 9. Tan inverse x plus tan inverse y equals to tan inverse x plus y whole divided by 1 minus xy. and secondly tan inverse x minus tan inverse y equals to tan inverse x minus y whole divided by 1 plus xy. Set 10. Cot inverse x plus cot inverse y equals to cot inverse xy minus 1 whole divided by y plus x, and secondly cot inverse x minus cot inverse y equals to cot inverse xy plus 1 whole divided by y minus x. Set 11. 2 tan inverse x equals to tan inverse 2x by 1 minus x square equals to sin inverse 2x by 1 plus x square equals to cos inverse 1 minus x square whole divided by 1 plus x square. Set 12. 2 sin inverse x equals to sin inverse 2x into 1 minus x square equals to cos inverse 1 minus 2x square. 2 cos inverse x equals to cos inverse 2x square minus 1. 3 sin inverse x equals to sin inverse 3x minus 4x cube. 3 cos inverse x equals to cos inverse 4x cube minus 3x. 3 tan inverse x equals to tan inverse 3x minus x cube whole divided by 1 minus 3x square. Dear students, now we are going to discuss problems belonging to the chapter Inverse Circular Functions, some of which are short answer type and some of them long answer type. In our State Council exam, we can expect 1 or 2 short questions from this part which carry 1 mark each and 1 long question which carry 5 marks. Now, first of all, the short answer type questions. Problem 1. Value of sin tan inverse x plus tan inverse 1 by x is a0, b1, c minus 1, d root 2. Choose the correct answer. Let us take first the given expression, and here we have to apply one formula from set 5 which is written in the box, that is tan inverse 1 by x equals to cot inverse x. Accordingly, we get the second step as sin tan inverse x plus cot inverse x, and here we have to apply another formula from set 6 which is tan inverse x plus cot inverse x equals to pi by 2, and we get the third step as sin pi by 2 which is nothing but 1, hence B is the correct answer. Problem 2. Prove that sin inverse x plus cos inverse x equals to pi by 2 holds if and only if mod of x less or equals to 1. Since we know that the value of sin theta and cos theta both are lying between minus 1 and plus 1, so we can let us consider x equals to sin theta or cos theta, whatever it may be, minus 1 less or equals to sin theta less or equals to plus 1, and minus 1 less or equals to cos theta less or equals to plus 1. Accordingly, we get mod sin theta less or equals to 1, and we can write mod x less or equals to 1. So in the right hand side also mod of cos theta less or equals to 1, and hence we get mod of x less or equals to 1. Since we take x equals to sin theta or cos theta, whatever it may be, theta can be replaced by sin inverse x or cos inverse x. Therefore, sin inverse x plus cos inverse x equals to pi by 2 holds if and only if mod of x less or equals to 1. Problem 3. Evaluate sec square tan inverse 2 plus cosec square cot inverse 3. So take the given expression first, and here we have to apply two formulae from our secondary education syllabus, that is 1 plus tan square theta equals to sec square theta and 1 plus cot square theta equals to cosec square theta, and accordingly we get the second step as 1 plus tan square tan inverse 2 plus 1 plus cot square cot inverse 3. Since we have tan inverse x equals to x and cot inverse x equals to x from set 1, we can apply the formula in the fourth step. We get 1 plus 4 plus 1 plus 9, that equals to 15. Next, problem 4. Prove that 2 tan inverse 1 by 3 plus tan inverse 1 by 7 equals to pi by 4. So starts from left hand side, that is taking the given expression in the left hand side, that is 2 tan inverse 1 by 3 plus tan inverse 1 by 7. So here we have to apply one formula from set 11, that is 2 tan inverse x equals to tan inverse 2x whole divided by 1 minus x square, and accordingly get as the first step here tan inverse 2 into 1 by 3 whole divided by 1 minus 1 by 3 whole square plus tan inverse 1 by 7. and after simplification we get the second step here as tan inverse 2 by 3 whole divided by 8 by 9 plus tan inverse 1 by 7, and accordingly we get tan inverse 3 by 4 plus tan inverse 1 by 7. Now we are in a position that we have to apply another formula from set 9, which is tan inverse x plus tan inverse y equals to tan inverse x plus y whole divided by 1 minus xy, and we get the fourth step here, that is tan inverse 3 by 4 plus 1 by 7 whole divided by 1 minus 3 by 4 into 1 by 7, and after simplification we get the fifth step as tan inverse 25 by 28 whole divided by 25 by 28, that gives tan inverse 1. This 1 can be replaced by tan pi by 4, and we get the sixth step as tan inverse tan pi by 4. Here we have to apply another formula from set 2, that is tan inverse tan x equals to x, and accordingly get the final step as pi by 4, which is nothing but our right hand side. Next, problem 5. Solve tan inverse half sec x plus cot inverse 2 cos x equals to pi by 3. Now solve for what? We have to solve for x, that is we have to find the value or values of x. So take the given equation first. So tan inverse half sec x plus cot inverse 2 cos x equals to pi by 3. So that we get the next step, to get the next step we have to apply one formula from set 5. This is cot inverse x equals to tan inverse 1 by x, and accordingly we get the second step as tan inverse half sec x plus tan inverse 1 by 2 cos x equals to pi by 3. So here if we simplify we get the third step as tan inverse half sec x plus tan inverse half sec x equals to pi by 3. Adding these two in the left hand side we get 2 tan inverse half sec x equals to pi by 3, and after simplification we get the fifth step here, tan inverse half sec x equals to pi by 6. So here we have to apply the definition of inverse circular function, that is tan inverse theta equals to x, then we get tan x equals to theta, and get the next step, that is half sec x equals to tan pi by 6. We know that tan pi by 6 is tan 30 degree. The value of tan 30 degree is 1 by root 3, and we get the next step as sec x equals to 2 by root 3 can be converted to cos x, that is cos x equals to root 3 by 2, which equals to cos pi by 6. So general solutions are x equals to twice n pi plus minus pi by 6, where n equals to 0, plus minus 1, plus minus 2, plus minus 3, dot 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 up to so on. So problem 6, evaluate sine cos inverse minus half. So take the given expression first. Here we have to apply one most important formula from set 4, which is cos inverse minus x equals to pi minus cos inverse x, which is written in the box. So accordingly get the second step as sine pi minus cos inverse half. So here if we apply the formula, that is we get sine cos inverse half, and accordingly here we have to apply another formula from set 3, which is written in the box in the right hand side, that is cos inverse x equals to sine inverse square root of 1 minus x square, and we get the fourth step as sine inverse square root of 1 minus half square. So that equals to sine inverse root 3 by 4. So here we have to apply another formula from set 1, that is sine inverse x equals to x, and accordingly we get the final step, that is root 3 by 4, that equals to root 3 by 2. So here we observe that here we apply 3 formulae, one from set 4 and another 2 from set 3 and set 1. Dear students, now we are going to discuss about the long answer type problems. Problem 7. If xy equals to 1 plus a square and x plus y plus twice a is not equal to 0, then prove that tan inverse 1 by a plus x plus tan inverse 1 by a plus y equals to tan inverse 1 by a. So let us take the left hand side as tan inverse 1 by a plus x plus tan inverse 1 by a plus y. We have to apply one formula from set 8, which is written in the box, that is tan inverse x plus tan inverse y equals to tan inverse x plus y whole divided by 1 minus xy, and accordingly get the second step as tan inverse 1 by a plus x plus 1 by a plus y whole divided by 1 minus 1 by a plus x into 1 by a plus y, and after simplification we get the third step as tan inverse a plus y plus a plus x divided by a plus x into a plus y whole divided by a square plus a into x plus y plus xy minus 1 divided by a plus x into a plus y. Since it is given in the problem, that is xy equals to 1 plus a square, so can be substituted here in the denominator part and get the next step as tan inverse x plus y plus twice a whole divided by a square plus a into x plus y plus 1 plus a square minus 1. Then after simplification get the second step here as tan inverse x plus y plus twice a whole divided by a into x plus y plus twice a square equals to, we get tan inverse x plus y plus twice a whole divided by a into x plus y plus twice a. So since it is also given in the problem, that is x plus y plus twice a is not equal to 0, so can be deleted from the numerator and denominator, and accordingly get the final step, that is tan inverse 1 by a, which is our right hand side. Problem 8, tan pi by 4 plus half cos inverse a by b plus tan pi by 4 minus half cos inverse a by b equals to twice b by a. We have to prove this. So taking the left hand side expression first and proceed for the next. So let us substitute theta equals to half cos inverse a by b, so that we get the result cos twice theta equals to a by b, which is written in the box. Then after substitution we get tan pi by 4 plus theta plus tan pi by 4 minus theta. These two terms can be defined as tan a plus b plus tan a minus b, and accordingly as expanded we get the third step. After substituting tan pi by 4 equals to 1, we have 1 plus tan theta whole divided by 1 minus tan theta plus 1 minus tan theta whole divided by 1 plus tan theta, and after simplification get the fourth step 1 plus tan theta whole square plus 1 minus tan theta whole square whole divided by 1 minus tan square theta. Then accordingly we get 2 into 1 plus tan square theta whole divided by 1 minus tan square theta. Since we have a relation from multiple submultiple angle which is written in the box, the formula cos twice theta equals to 1 minus tan square theta whole divided by 1 plus tan square theta, and if we substitute here we get the last part before step, that is 2 by cos twice theta, and finally get twice b by a, which is nothing but our right hand side here. Next problem 9, if cos inverse x by a plus cos inverse y by b equals to theta, then prove that x by a whole square minus 2 into x by a into y by b into cos theta plus y by b whole square, that equals to sin square theta. Let us consider the given equation first, that is cos inverse x by a plus cos inverse y by b equals to theta. So we are in a position to apply a formula from set 8, that is cos inverse x plus cos inverse y equals to cos inverse inside second bracket xy minus square root of 1 minus x square into 1 minus y square. So if we apply, we get the next step here, cos inverse inside second bracket x by a into y by b minus inside square root 1 minus x square by a square into inside square root 1 minus y square by b square, that equals to theta. So we here apply the definition of inverse circular function, that is if cos inverse x equals to theta, we get x equals to cos theta, and accordingly get the next step here, that is x by a into y by b minus square root of 1 minus x square by a square into square root of 1 minus y square by b square, that equals to cos theta. So if we take this arrangement, we have square root of 1 minus x square by a square into square root of 1 minus y square by b square, that equals to xy by ab minus cos theta. To eliminate this square root term, we have to square both sides. So here, squaring both sides, we get 1 minus x square by a square into 1 minus y square by b square, both are in the first bracket, that equals to xy by ab minus cos theta whole square. So in the left hand side, if we perform the multiplication, we get 1 minus x square by a square minus y square by b square plus x square by a square into y square by b square. So in the right hand side, that is the whole square, that is x square by a square into y square by b square minus 2 into x by xy by ab into cos theta plus cos square theta. So if we make the arrangement, that is 1 minus cos square theta equals to x square by a square plus y square by b square minus 2 into xy divided by ab into cos theta, and finally get the required result. Therefore x by a whole square minus 2 into x by a into y by b into cos theta plus y by b whole square, that equals to sin square theta. Next, problem 10. If tan inverse x plus tan inverse y plus tan inverse z equals to pi by 2, then prove that xy plus yz plus zx equals to 1. Let us consider the given equation first, and here we have to apply one formula from set 9, which is written in the box, that is tan inverse x plus tan inverse y equals to tan inverse x plus y whole divided by 1 minus xy, and accordingly get the next step, that is tan inverse x plus y whole divided by 1 minus xy plus tan inverse z equals to pi by 2. Again we apply the same formula here, and here in the screen the last step, that is tan inverse x plus y divided by 1 minus xy plus z whole divided by 1 minus x plus y divided by 1 minus xy into z, that equals to pi by 2. So here we are in a position to apply the definition of inverse circular function, that is if we consider tan inverse x equals to theta, we can write x equals to tan theta, and accordingly get the too much simplification here in the third step in the screen, that is x plus y plus z minus xyz whole divided by 1 minus xy minus yz minus zx equals to tan pi by 2. The numerical value of tan pi by 2 is 1 by 0. If we cross multiply, we get 0 equals to 1 minus xy minus yz minus zx, and finally get the result, that is xy plus yz plus zx equals to 1. Now problem 11. Solve. Sin inverse 5 by x plus sin inverse 12 by x equals to pi by 2. So solve for what? We have to solve for x, that is we have to find the value or values of x. Now solution. So if we consider the given equation first, write it. So sin inverse 5 by x plus sin inverse 12 by x equals to pi by 2. Now consider the second term in the left hand side. Let us bring it to the right hand side and get the second step as sin inverse 5 by x equals to pi by 2 minus sin inverse 12 by x. Now here in the left hand side we have to apply one formula from set 3, which is written in the box, that is sin inverse x equals to cos inverse square root of 1 minus x square. And for the right hand side we have to apply another formula from set 6, which is also written in the box, that is sin inverse x plus cos inverse x equals to pi by 2, which gives the result cos inverse x equals to pi by 2 minus sin inverse x. So if we use these two formulae, we get the next step here. Also here we have to substitute the expression in the right hand side, pi by 2 minus sin inverse 12 by x can be substituted by cos inverse 12 by x, and we get the step here, the first step, cos inverse square root of 1 minus 5 by x whole square equals to cos inverse 12 by x. After simplification we get square root of 1 minus 25 by x square equals to 12 by x. To eliminate the square root term, we have to square both sides here again. So squaring both sides, we get 1 minus 25 by x square equals to 144 by x square. So in this step, the fourth step, if we consider all the terms containing 1 by x square in one side, here it is in the right hand side, we get 1 equals to 25 by x square plus 144 by x square equals to 169 by x square. So if we cross multiply, we get the next step, that is x square equals to 169, that equals to 13 square. So if we take the square root, we get x equals to plus minus 13. The answer must be written in this way. Therefore, the required solutions are x equals to plus minus 13. So here we get two solutions, x equals to plus 13 and minus 13. Also we see that here we are applying two formulae, one from set 3 and another from set 6. And dear students, in the screen next there are some exercises are given which for your assignment for practice. Thank you all. Dear students, in Unit 3 Trigonometry, there is another subunit 3.6, namely Properties of Triangle. In this chapter, only the basic formulae here included in our syllabus. Our discussion is to observe the formulae. First of all, our task is to follow the notations that are used for several parts of a triangle. So, let us consider ABC be a circumscribed triangle. We consider capital A equals to angle BAC, capital B equals to angle ABC, capital C equals to angle ACB. Small a equals to length of the side BC, which is opposite to the angle A. Small b equals to length of the side CA, which is opposite to the angle B, which are all in the figure in the right hand side. Small c equals to length of the side AB, which is opposite to the angle C. Delta gives the area of the triangle ABC. Capital R equals to circumradius of the triangle ABC. So here in the figure twice R denotes the diameter of the circle. 2 small s equals to perimeter of the triangle ABC, that is 2 small s equals to small a plus small b plus small c. So the formulae part. Following are the properties involving above. Here all the small letters are denoted the sides of the triangle ABC, and capital A, capital B, capital C denote the angles of the triangle ABC in the picture. Now set 1. A by sin A equals to B by sin B equals to C by sin C. Secondly, A by sin A equals to B by sin B equals to C by sin C equals to twice R. Set 2. A square equals to B square plus C square minus 2BC cos A. Here BC cos A means BC into cosine of the angle between the sides B and C, and same for the next two. That is B square equals to C square plus A square minus 2CA cos B. C square equals to A square plus B square minus 2AB cos C. Set 3. A equals to B cos C plus C cos B. B equals to C cos A plus A cos C. C equals to A cos B plus B cos A. Set 4. Sin capital A by 2 equals to inside square root S minus B into S minus C whole divided by BC. Sin capital B by 2 equals to inside square root S minus C into S minus A whole divided by CA. Sin capital C by 2 equals to inside square root S minus A into S minus B whole divided by AB. Set 5. Cos of angle A by 2 equals to inside square root S into S minus A whole divided by BC. Cos of angle B by 2 equals to inside square root S into S minus B whole divided by CA. Cos of angle C by 2 equals to inside square root S into S minus C whole divided by AB. Here in set 6 there are different expressions of delta, that is the area of the triangle. First, delta equals to half BC sin A. This BC sin A means BC into sine of the angle between the sides B and C, and same for the next two. That is, secondly, delta equals to half CA sin B, delta equals to half AB sin C. Set 7 capital R equals to small abc by 4 delta. Set 8 gives the area of the triangle, that is delta equals to inside square root s into s minus a into s minus b into s minus c. That's all. Thank you.